Hello, Atanasov, Gates, Hollerith, Hopper, Iverson, and Neumann, and welcome to another video LAS instruction for quarter 4. And this time we will be tackling week 5 and how are you going to understand it and what are the things that you need to finish related to it. Ayan. Week 5 is about energy transformation and conservation, and you are supposed to read the following background information for you. Okay, so our cell phone, halimbawa, the thing that you're using right now, or maybe your laptops, they need their batteries recharged, or else once they run out of power, they'll stop working. Another example of how energy is affecting our lives is the need for us to eat a few hours every day just to get through each one. Also, for our lalo na for our face-to-face class students who are now viewing these last instructions, you know fairly well that the car that was used to send you to school and to pick you up from it, they also need to burn fuel for them to run. And everywhere we turn, energy has to be obtained talaga from something. We can't just, magically produce energy. There always has to be a source for energy. Okay, so what we do is we are just converting energy from one source. Okay, so example, kanina dun sa pag-i-eat natin ng food, yung energy na galing dun sa plant, galing na niya rin yun from other sources. Like, galing niya yun from the sun, galing niya yun from the nutrients that was sucked by its roots. Ayan. And then yung halimbawa, energy from the sun, it also comes from something like, say, for instance, the fission or the fusion of various particles, various elements leading to the production of that massive amount of energy. Energy is not created, it's not also destroyed. What happens to energy is that it's only transformed, okay, from one form to another. Energy is indeed the name of the game, and it is essential to life and all organisms. It is what is making everything work. It is stored in different forms, and it can also be transferred into different places through different means. Like I think you're already familiar with convection, conduction, at saka um, radiation by now, since you guys studied that in grade 8, right? Okay. What else? It can also be transformed during transfers. Yes. Now, our module is going to focus much on energy, pero it's gonna work on the transit. It's transformation. Okay. So energy transfer refers to the movement of energy from one place to another. So, halimbawa, yung electricity from the wall socket, it can move through a charger into a battery and to the phone. Okay. Now, the energy is being transferred from the wall socket nun to the battery. Yun yung transfer. Yun yung pagta-transfer lang or paglilipat lang ng energy, no? From one place to another. Iba pa yung mismong transformation naman. Kapag nata-transform yung energy, ibig sabihin, it takes a new form. Okay? Transform. Okay, so examples are, halimbawa, the writers showed us the following. Halimbawa, the sun transforms nuclear energy into heat and light energy. So, yung sinabi ko sa inyo kanina, yung mga nuclei, yung mga nucleus ng mga elements na nag-divide or yung mga nucleus din na nag-collide, merong kakayahan yon na mag-produce ng napaka taas na amounts of energy. Okay? Tapos kapag ganun, ang nagpo-produce nila is heat or thermal energy o kaya light energy. Ayan, our bodies as well, they convert chemical energy in our food, tas pwede siyang gamitin into mechanical energy, which allows us to move around. Ayan, electric fan naman, it transforms yung nare-receive niyang electrical energy into mechanical energy rin. Okay, that's a correction for this one. And then yung lightning naman, yung lightning, it's actually electrical energy that is converted into light. Kaya kapag lumilindol, merong light, tas meron ding thermal energy na napoproduce, meron ding sound energy. Okay. Now, magmula kanina, pinag-usapan na natin yung fact na hindi talaga nade-destroy at nag-create ang energy. Bakit kaya ganon? That is a physical phenomena, and it has been a law kasi it doesn't really change. Okay, almost anywhere in our planet, anywhere in this galaxy, in this universe, energy is neither created talaga nor destroyed. And that is actually what we call as the law of conservation of mechanical energy, or law of conservation of energy as a whole. In the next part of this part of your learning activity sheet, the writers are presenting you with the following terms. First one is mechanical energy. Mechanical energy is the capacity ng isang object to do work by the virtue of its motion or configuration or position. A mechanical energy is the sum of the following energies: the kinetic energy at saka potential energy. Kapag pinagsama mo silang dalawa, kinetic and potential, what will you get? It's mechanical energy. And mechanical energy again is yung kapasidad ng isang object para makagawa siya ng work related sa kanyang galaw at saka dun sa kanyang composition at dun sa kanyang position. Okay, this is going to be more clear as we progress through this part of the module. Now, the first one that makes up mechanical energy is kinetic energy. Ang kinetic energy daw is the ability of an object na makagawa ng work by virtue of its motion. Okay, so halimbawa, ang kinetic energy ng wind, meron siyang capacity na i-rotate yung blades ng isang windmill, and therefore, that is going to produce electricity. Electrical energy is the product of the motion of the windmill. Ang kinetic energy ng wind is described as its ability to turn the windmill. Now I know, medyo nakakaano to, pero nakakalito ito for some of you. Pero just think of it like the way it was defined to you before, that kinetic energy is energy in motion. Okay? Okay. Okay, now, it's expressed as KE, tapos yung kanyang unit is joules. Okay, so it's symbolized as J, which is equals to 1/2 of the M, or the mass, of the object in kilograms multiplied by the square of velocity, which is the velocity of the object expressed in meters per second. Yung velocity, is-square muna siya, okay, as it was shown in this formula. Square mo muna siya, and then multiply the square by the mass. Ngayon, napapansin nyo, kung halimbawa yung velocity dyan is 0, ibig sabihin nun, ang buong yan, kinetic energy, is going to become 0. Just imagine. 0 raised to 2 is 0, multiplied by mass is 0, divided by 2 is also 0. Okay, kapag 0 yung velocity, ibig sabihin kasi nun, hindi gumagalaw yung object. Therefore, wala siyang kinetic energy. Okay? Again, if the object is at rest, it doesn't have kinetic energy. Okay? That's why, remember that kinetic energy is energy in motion. Next one, potential energy is the ability of an object to do work by the virtue of its configuration or position. Yung configuration niya is kung ano yung composition niya. Okay? Kung ano yung what makes it up. Okay? At saka ano yung mga properties na mayroon siya. I'm not sure if I can change the color of this, but okay, I don't think I can. Okay, for example, a compressed spring can do work when released. Okay, again, it can do work when released. It has that potential to do work, but it has to be released first. Okay? Unlike kanina na yung wind, it already has talaga the ability to do work because it's already in motion. Potential energy, in this case, has the ability pa lang to do work once it's released. Potential energy can be expressed as U, which is the potential energy of the object in joules. M is the mass of the object in kilograms. G is the gravitational constant of the Earth, which is 9.8 meters per second squared. And H is the height of the object from the Earth's surface. Okay, now we know that the acceleration of an object under the influence of the Earth's gravitational force will vary to its distance from the Earth's center of gravity, but the surface heights are extremely small when compared to the Earth's radius. That, for all practical purposes, g is taken to be constant. Let's continue reading. The sum total of an object's kinetic and potential energy at any given point in time is its mechanical energy, as it was said a while ago. Okay, so this means that the law of conservation of energy will state that energy can neither be created nor can it be destroyed. So it means that under a conservative force, the sum total of an object's kinetic and potential energies remain constant. Before we dwell on this subject further, let us concentrate on the nature of the conservative force. Well, what all of this is trying to tell us actually, ito pa lang ha. Anyways, this formula, I would like to correct that this formula is not the only formula for potential energy. Okay, but your learning activities sheet is actually showing you right now U is equal to mgh, that is gravitational potential energy. Okay, let me repeat that. Potential energy that has the formula U is equal to mgh. That is actually gravitational potential energy. Okay? Yung spring naman na to, itong spring, it's not actually an example under gravitational potential energy. Okay? Springs and any elastic bands, okay, they are under, actually mostly springs, they are under elastic potential energy. Okay? So, yung spring na explain ko na kanina that, when released, it has the ability to do work. Same goes for things na like, because that is elastic potential energy. Now, for gravitational potential energy naman, things that are put in a position, okay, sa planeta natin, in a particular position at a particular height, those have the ability to do work when they are let go. Okay, yun yung potential nila. That is how potential energy works in them. Okay, after correcting that, I would like to also point out that the law of conservation of energy was explicitly stated here that energy can neither be created nor destroyed. Hindi siya pwedeng ma-produce like as in from nothing. Okay, kailangan merong source lagi ang energy. Tapos, kapag ginamit siya, hindi siya basta-basta mawawala. Okay, so matatransform lang siya into other forms, pero andyan pa rin siya for sure. So therefore, sabi nga niya kanina, dapat the total amount of mechanical energy must be equal to the sum of the kinetic and potential energy. Conservation involves a quantity that remains the same even other quantities change. The principle of conservation of mechanical energy states that in an isolated system that is only subject to conservative forces, the mechanical energy is constant. If an object moves in the opposite direction of a conservative net force, the potential energy will increase. Again, If an object moves in the opposite direction of a conservative force, dadagdag yung kanyang potential energy. And if the speed, not the velocity, of the object changes, the kinetic energy of the object also changes. Whatever happens in the mechanical energy in one side will surely affect the kinetic and the potential energy on the other side. That is the concept of conservation. The next part of your learning activity sheet is describing conservative forces. It is derived from a scalar quantity. Remember, a scalar quantity only has magnitude regardless na siya of the direction. For example, the force causing displacement or reducing the rate of displacement in a single dimension without any friction involved in the motion. What kind of force is that? Again, it says here, a force that causes displacement or a force that reduces the rate of displacement in a single dimension nang hindi gumagamit ng friction. The work done by a conservative force depends on the endpoints of the motion. For example, if the work is done, uh, kinetic energy, the final kinetic energy of the object at the final position, and the initial kinetic energy of the object at the initial position will be equal to the following. So you just have to get work, okay, you just have to get the difference between the amount of kinetic energy after and the amount of kinetic energy before, okay, in their respective places, in their respective positions. The work done by a conservative force in a closed path must be zero. Here, W is the work done, F is the conservative force, and D is the displacement vector. Remember in grade 8 when we described how work is solved for, our formula was W is equal to F times D. Okay, so in a closed system, the application of force that is along a particular distance is going to result to work. In case of a closed loop, the displacement is going to be zero. Hence, the work done by the conservative force is zero regardless of its magnitude. What that is trying to tell us is if D is zero, dito, if D is zero, work is going to be zero regardless kung meron kang in-apply na force, okay? Again, if it didn't really cover any displacement, wala talaga siyang tinravel na plane, it's zero distance, then that's gonna result to zero work as well. No work is done. I think that was also described to you when you were in grade 8. Now, let's consider now the following figure. Here, delta D, or the change in displacement of the object under the conservative force F. By applying the work energy theorem, it must result to the change in kinetic energy is equal to the force applied along the horizontal and the change in D. Since the force is conservative, the change in the potential energy can be defined as the change in V is equal to negative change in force x times delta D. Well, as my students, I think that at this point you are very much confused already. I understand that. That is why at this point we are going to end the reading of the background information for learner. Okay, so we'll be skipping this one, the single pendulum, and then we'll be directly tackling the following activities. Our learning competencies, remember, is just for you to perform activities to demonstrate the conservation of mechanical energy. Okay, so let's just stick to that. Now, activity number 1, let's try. What you need to do here is just to look at the theoretical makeup of the following setup. Okay, so if the cart is at this point in A, and then B, and then C at this point, and then D right there, you just have to describe the amounts of potential and kinetic energies that it has. Okay, So please make sure that you take a photo or screenshot of your answers to the following questions. Tapos make sure that you check your work, and you also indicate the score. Make sure that you put that in your portfolio. Okay. For the next one, activity 2, I am going to ask you to skip this activity. Okay? Again, you are to skip activity number 2. Okay, so that is it for week 5. Um, we are about to end the school year, and I am really hoping that you use the resources that I am giving you, and that you listen as well to our online classes, to our face-to-face classes, and that you finish the tasks I am asking you to finish, so that comes the end of the school year, by the end also of this month, wala na kayong maraming mga backlogs. Okay? At this point, I would also like to remind everyone to please make sure that you have taken all of the quizzes that you need to take, and that you have also finished other required tasks that I am asking from you. Double check them in Edmodo. Double check them by opening them, and make sure that more or less when I open your portfolios, all I have right there are tasks that are supposed to be there. So you really have to listen when I tell you through these instructions what to do and what to skip. Okay, that is it. Grade 9, Natanasov, Gates, Hollerith, Hopper, Iverson, and Neumann. I'm hoping that these resources are helpful for you in finishing your portfolio and in understanding as well the topics that we are discussing. I hope that when you have questions about this, you're gonna raise them then through our online classes. I would like to see you in our online classes every Wednesdays.